Hi class, let's look at this problem here. This is another problem that utilizes Binford's law. Of course, we're not going to be able to use Excel but on our final if we see this problem, but you can do this by hand if you wish, but I'm going to do it in Excel for expediency purposes. So in order, I have the observed results here, and I have to calculate the expected results based on Binford's law. So in order to do that, I need to add up all of these values. So there's the result right there. And I need to multiply these percentages by 781. So it's going to be, this first answer is going to be this number times 781. And then I can just copy this down the page. And these are the expected results for each one. So now, just to make this simpler, let me go ahead and move this over here. I'm just going to copy the numbers and then do the actual numbers and move these right here. Okay, and now the observed and the expected are side by side. Remember, okay, to keep all of the decimal places, do not round for the expected results. I need those decimal places. Even though the number may not make sense numerically or within the context of the problem, I need to have this. So now let me copy these results and put them directly into StatCrunch. There they are right there. So you're going to have some, if you see this problem on the final, you're going to have some legwork here, because you're going to have to, since you're not going to have the benefit of Excel, you're going to have to do all of these calculations manually on your piece of paper. And they're easy to do. Just add up all these values and then multiply this total by each of these percentages to get these expected results. Okay, and then just input them side by side in here. Now StatCrunch can take over from here, and it's very easy. Stat, goodness of fit, chi-square. The observed column is var1. The expected column is not going to be equal, so don't do the equal proportion one. This is Binford's law. Okay. So we do not want to select this. We actually have to give the expected results because they are not the same for Binford's law. Compute. Here's my chi-square right here, 13,506. My p-value, 0.0956. And alpha, they told me in this problem, was 0.01. The p-value is bigger than alpha, therefore we are going to fail to reject the null. There is not sufficient evidence to warrant the claim. It confirms that it does not appear that the checks were the result of fraud. Okay, so in essence, what we've established here is that since we did not reject the null, it does not appear that these checks were fraudulent. Thank you.